In this video, I'm going to show you how to name ionic compounds. And ionic compounds are formed between a metal cation and a non-metal anion. So a metal that has a positive charge and a non-metal anion that has a negative charge. And in this worksheet, I've highlighted all of the metals blue and all of the non-metals red to kind of help me separate the two in the compound. And the periodic table, hopefully you know by now, these groups represent certain charges that these atoms can become when they form ions. So group 1 forms positive 1, group 2 forms positive 2. This group here forms a positive 3. Group 17 all the way over here forms a negative 1 anion. Group 16, negative 2. Group 15, negative 3. And so we're going to need that to determine the charges of certain ions. In the center here we have transition metals, and for those transition metals they can form multiple charges, different charges of ions, and so we'll look at that in a little bit. And so here we have some cations. These mostly show transition metals, and then this chart right here we'll use. This has polyatomic ions, which we'll look at in a second. Those are just simply ions made up of many atoms. So let's say you needed to name an ionic compound from a formula. So you're given something like K2O and you need to write the name. What you need to do is write the name of the metal first, then write the anion but change its ending to IDE. So if you had chlorine at the end, it would become chloride, or oxygen would become oxide. So if I had this here, K2O, K is potassium, that's my metal. I've highlighted in blue. I'm just going to write potassium, and it's joined with an anion of oxygen, and oxygen is just going to change to oxide. So I have potassium oxide. This example, lithium is my metal, chlorine is my anion. So I'm going to write my metal, which is lithium, and chlorine would change to chloride. That's pretty simple ionic naming. If I wanted to do the opposite and write the formulas, or if I were given something like magnesium chloride as the name and I needed to write the formula, it's going to be a little bit different. If I do that, charges matter. I need to figure out the charge of the cation and the charge of the anion, and I need to balance those charges. And the number of ions I need of each type is then shown by the subscript. So I always say start by just writing the symbol and the charge of that ion. So magnesium is Mg, forms a positive 2 charge. Chlorine, right, chloride is actually chlorine, has a negative 1 charge. Now at this point I have more positive charges than I have negative charges. So what I would need is another chlorine ion with a negative 1 charge. Now I have a total of positive 2 and a total of negative 1. Those charges would balance. So when I write this formula, I start with my metal, magnesium. I only have one of them. Then I have chlorine, and I have 2 chlorine ions in this compound. So it's going to be Cl2 to represent those 2 chlorine atoms, or 2 chlorine ions that I need in this compound. Another one here, beryllium phosphide, beryllium, Be. Good look here, beryllium has a charge of positive 2. Phosphide, that's phosphorus, and phosphorus has a negative 3 charge. So this one's a little tricky because you may see, well, I'll just add another beryllium. So I have now positive 4, negative 3, so I have another phosphorus. Now I have positive 4, negative 6. I'm going to need one more beryllium for positive 6, negative 6. Those balance out. Beryllium, I've got 1, 2, 3 of them. Phosphide, I've got 2. Be3P2. Okay. Now if we had formulas or names with polyatomic ions, here's where you would need to use your reference sheet. And polyatomic ions are very simply ions made up of multiple atoms. So carbonate, for example, CO3 is made up of 4 atoms, 1 carbon and 3 oxygens, and it has a total charge of negative 2. So this whole thing, CO3, has a charge of negative 2. Okay. Charges need to balance in the compound just like before, but IDE is not added to the end of the ion, or to the end of the anion, which we'll see in examples 3 and 4. So I've got calcium hydroxide. Calcium is Ca, and it has a positive 2 charge. Hydroxide, we're going to look at my reference sheet here. Hydroxide is OH, and it has a negative 1 charge. I've got OH, negative 1 charge. So right now I've got calcium with a positive 2 and one hydroxide with a negative 1. I'm going to need a second hydroxide to have my charges balance out. And so here's how I would write that. I've got my 1 calcium, and if I want 2 polyatomic ions, I need to put the polyatomic ion in parentheses. And the 2 is going to go outside the parentheses to show that I have 2 of everything inside of the parentheses. In this case, hydroxide. So I have CaOH2. So other example here, aluminum phosphate. Aluminum is +3. Phosphate, we're going to look at my reference sheet. Phosphate is PO4, and it has a negative 3 charge. Positive 3, negative 3, those charges balance. So I can just write AlPO4. Now if I were going the other way around, and I had my metal and my polyatomic ion written in a formula, I'm just simply going to start by writing the metal, which is calcium. Then I'm going to write the name of the polyatomic ion. And if I looked at the reference sheet, I would see that CO3 is just carbonate. So I have calcium carbonate. So next example, I have LiNO3. Li is lithium. And if I look to my polyatomic ion sheet, NO3 is nitrate. So I have lithium nitrate. Okay, last but not least, naming with Roman numerals. All the same rules apply as above, but the Roman numeral just simply tells you the charge of the transition metal. So in this example, iron 2 oxide, I've got a Roman numeral 3 for iron. Sometimes iron can be iron 2 and have a charge of 2, but in this case, iron is iron 3. So that means this 3 tells me that iron has a positive 3 charge, and it's bonded together with oxygen, which has a negative 2 charge. And so for these charges to balance, I would need a total of 2 irons and 3 oxygens, Fe2O3. Now I can work backwards. Copper is a transition metal, and I can figure out its charge by figuring out what it's bonded with. Now it's bonded with 2 chlorines, and each of these chlorines is going to have a negative 1 charge. So that's a total of negative 2, which means my 1 copper must have a positive 2 charge. So when I write the name, it would be copper, and I would use this 2 to represent the charge of copper in Roman numeral, chloride. And that's ionic naming. Try to give these a shot and see how you do. I'll post the key on Schoology.